All right, here's the next segment. And so how do we know that this works? It all sounds great, but where does the rubber hit the road? And that's why we've got the independent lab test. We've never actually met the lab, one of the most prominent labs in the United States. And they're currently running another test for us, which we'll go at and look at just as we finish these slides. The organisms that I chose 5 years ago were chosen because they were the toughest of the bunch. In other words, if I got a 5-year-old banging my leg, it's not going to hurt me. But if George Foreman hit me in the leg, I'm going down. So these are the ones that are the toughest challenges. Of the mold species, and that's the one in the top left-hand corner, Aspergillus niger is the hardest to subdue. Nothing comes close. And so just to give you a scale, bacteria and virus can absorb a certain amount of energy, and generally they fall when they absorb between maybe 8 and 12,000 UV energy units. Aspergillus niger, that particular brand of black mold, and there are different types of black mold, requires 330,000 energy units. So it gives you some idea how tough that is. In other words, how much energy it can absorb. So when you're looking at trees out of doors and you'll see moss or something growing on one side, you've got to believe that that is a very, very rugged organism, hard to kill. Of the molds that are out there, we speculate, that is worldwide, that there's between 5 and 6 million. Of those 5 and 6 million, 75,000 have been tested and looked at and studied. Of the ones we know of, that's the hardest to kill. So you can see that in 48 hours, we've got a 99.9 kill. So if you run our unit over the weekend, the spores are the first ones to die because that's what it sneezes out as its offspring, and it can sneeze out several trillion in a few days. And then it goes after the main colony. So even though you're going to see that the mold is there, it is dead. It's non-resurrectable. It cannot be encouraged to grow in a petri dish that has an agar solution or different solutions or a broth. It's non-replicatable, which is very interesting. On the tests that we do, it's highly unusual that we're not only testing on a hard surface as stainless steel, but also a soft surface. Chemicals do not work well at all on soft surfaces, so that we've got a similar kill or sometimes a better kill on soft fabric is remarkable. So think of your hospital room, that not only am I looking after the hard surfaces, but it's the sheets that are touching the individual. It's the drapery that you're pulling around the bed, that when you actually swab that area, it's in the tens of thousands, or at least in the thousands of bacteria. We grab things in the same place usually. And so anybody that grabs that sheet now pulls it back to look at the patient, examines under the throat, the ears, and all of a sudden you've passed bacteria or virus to that patient, which was not your intention. More common ones that we've heard about, like a staph infection, which is Staphylococcus aureus. In 4 hours, we got a 1.2 log reduction, but in 12 hours, it was 5.1, which was total destruction at 99.999. So the longer we run the equipment, that's more of energy that's heading towards these microorganisms we want to control, and that's something you cannot do with chemistry, or chemical. So if you're running this 24/7, you will get those benefits, and we recommend that you don't turn it off. Once it's on, keep it on, unless it's just a job where it's just clean up, you get the job done and leave. The next one is E.coli on food, stainless steel. 4 hours, it maxed out in 4 hours. So even though it says greater than 4.2 log reduction, that means coupled with air movement, there was nothing left to kill. So within the 4 hours, it was total destruction. And very similar with the cotton fabric. Moving down to pseudomonas is what your lungs would fill up with oh my gosh, what is that? Pseudomonas is, I always remember the Latin name, I can't remember the normal one. Pneumonia, there you go. That's what your lungs are going to fill up with. And so within 4 hours, it was a 5-point log reduction, so 99.999, and total kill at that point. So those are the ones that are hurting us when we're going into the daycare centers and where our children are. And of course, we've got the flu season, so this is the next slide here. And at 3 hours, we got a 99.98 kill, so 3.7. And within 6 hours, it was totally gone. And even better results on cotton fabric. Listeria, for the cheese industry, many other ones in the food industry, they have an issue with listeria. And so we have to be able to control that while it's running. And the neat thing is that you can run this while the food is in production. It's not going to hurt the food. So we've done taste tests for 4 months in the brewing industry. So we didn't alter the flavor. We didn't degrade the look. and the mouthfeel didn't change. So those are the things you cannot change when you're dealing with food and beverage. It has to stay the same, or at least better would be great. But again, the atmospheric hydroxyl comes to the rescue, is able to do that. In hospitals, C. difficile is very, very hard to control. We were able to do that. The very last one is kind of unusual in that it's not the usual mix you would see, and that's in the hog industry. 30 to 35% of our hogs die because of PRRS. It affects the respiratory system as well as the reproductive system. And to be able to address that, as well as the extreme odors that are coming from barns, not that you would have that in your home, but if there's a sewer backup, if you're close to a dump site where there's, the refuse has been piled up and those gases happen to go your way, that would mean that inside your home it would be odorless. It would be able to handle that. So our home may be in great shape, and we take pride in keeping it neat and clean, but we're at the mercy of what's coming our way, and then it's inhaled into the duct system, and then it's recirculated. So we'll have something that will work very well with that. To add to this, we will have that we've done salmonella rather. Salmonella, we picked the hardest to kill, which was the enterica, and the serotype was typhimurium. And so it takes almost double the amount of energy to kill that particular type of salmonella compared to the 2,499 other ones that are out there. So basically 2,500 salmonella species we picked the hardest to kill, totally subdued within an 8-hour period. The current one that we should get results on this week is CRE. So that is an emerging disease that we have no defense for, and that is talking about in the world of CDC that they operate. So usually for what we see here, there's a protocol, whether it's chemical or it's a biological in the form of antibiotics. CRE is resistant. That's what the R stands for, resistant to our best antibiotics. So we're totally at the mercy of something that has a very heavy death toll associated with it. And so to be able to handle new and emerging diseases means that the idea behind what we do, in other words, donating more electrons than the entity can handle, holds up for something that's new and emerging, for which there is no defense. So a very good point to ponder. And so who would run the machine just for 3 hours and shut it off? If we've got it on a weekend, we run it through an 8-hour shift. While you still will have to do the mechanical cleaning, the physical moving of blobs and pieces of meat or debris from the food field, that has to go. That will never change. But to be able to have a sanitizer and towards disinfectant, towards sterilant, depending how long you run it, able to run in the background for 24 hours a day, you're not looking at just the surface, but you're looking at the belts that take the food from the slaughter floor to prep to final finish, or where the food is when you chop it up and get it going. So your concrete is being handled. How much comes off of concrete, or comes off of the beams that are up there that we can't address, or it's locked inside the AC HVAC system. That's how Legionnaire's disease was proliferated. Enough got up into the drip pans, and it was just blown on everyone that was there. So to be able to be slightly lighter than air and be vacuumed up into that system and sanitize that as it rolls along is something that nothing else can do. Very interesting. Or you could spray it, but then as soon as the AC system turns over one time, it's dirty again. So it's a continuous pressure on the microorganisms that they can't get a toehold, a beachhead, and then proliferate and cause us grief. So in that dreaded word R for recall is going to start dropping, which is what we want to see in that food industry.